Alright, so we have a binomial theorem. If x and y are arbitrary real numbers and n is a non-negative integer, then we can expand x plus y to the power n with a binomial expansion. So in order to expand this x plus y to the power n, we can simply say as k changes from 0 to n, we write down the binomial coefficients and we say x to the power k times y to the power n minus k. So the power of x increases 1 by 1 as the power of y decreases 1 by 1, and always we update with binomial coefficients. Okay. So how do we prove that this equation works? It can be proven by induction. Okay, so we can prove this statement when n is equal to 1, and when n is equal to 1, it is simply going to be x plus y. And then we assume that this equation is true for n, and once it is true for n, we can also prove it for n plus 1. So by induction, we can show that this is always true. Now, we can use the binomial theorem to expand these two numbers, x plus y to the power 3 and x plus y to the power 4. And how do we do that? So we can basically use the formulation k changes from 0 to 3, and we have 3 choose k times x to the power k times y to the power 3 minus k. We can simply plug in the k values in each of these 4 components in the summation, and that becomes y to the power 3 plus 3 times x times y to the power 2 plus 3 times x squared y plus x to the power 3. We can use the same formulation for expanding x plus y to the power 4. We can also expand x plus y to the power 4, again with the binomial coefficients as k changes from 0 to 4. 4 choose k times x to the power k times y to the power 4 minus k. By plugging in x values, we can get this formula. These are the things that you are already familiar with in the high school, I suppose. I mean, we were using this Pascal triangle for this binomial expansion. Now, this is important for us because we are going to use this formulation in our future lectures. And in fact, we are going to use that in the following question, which is question 14. How many subsets can we have in a set of n elements? The answer should be 2 to the power n. So there are 2 to the power n different subsets of an n element set, including the set itself and the empty set. So how do we count this? There are 2 ways of doing that. Remember now, the number of k element subsets or k element combinations is formulated by n choose k. So we can simply say we can count the number of k element subset as k changes from 0 to n. And when we sum them up, we are going to get the total number of possible subsets. Okay, so this is our answer. This is our answer. Now, I'm going to make a trick here. And I'm going to put 1 to the power k and 1 to the power n minus k as a multiplier next to n choose k in each term. And this is not going to change anything because 1 to the power k is always 1 as 1 to the power n minus k. So the result of the first part and the second part should be the same because 1 is an ineffective multiplier. But once we construct this form, according to the binomial theorem, we can rewrite this summation as 1 plus 1 to the power n, which is simply 2 to the power n. So we are basically using the binomial theorem to prove that there are 2 to the power n subsets in an n element set. You can also find this number again using the idea that we have used in the coin flip question. So remember, we were flipping a coin n times consecutively. Each time we have 2 possible results, right? Now imagine this, we have n elements in the whole set, and each element can either be put in the subset that we are creating or not. So when we are creating a subset, we are basically doing this. We decide if a certain element is going to be in that subset or not. So there are 2 alternatives in each decision. So for each element, we need to make a decision, each of which has 2 alternatives. Therefore, there are 2 to the power n possible decisions to create a subset. Therefore, we have 2 to the power n possible subsets here.